Good morning. I'm about to show you how I can use Gemini CLI to do all kinds of amazing things on an HPC cluster. Okay, so this screen that we're seeing right here was already has some stuff on it from before. Let me move this out of the way. Okay, so this already has some stuff on it from before. Had it tell me how the last astrophysics simulation progressed, and if it completed, of which it did, and of which Gemini CLI created the whole thing for me. It uses both CPU and GPU nodes to calculate or simulate a galaxy and find a black hole, I believe. So, and then it actually created a plot that you can see right here. But what did this sim did this astrograph do? Okay. Oh, awesome. Imagine you're trying to find a specific faint whisper in a very noisy stadium. Astrophysics workflow ran a simulation of that exact process for finding gravitational waves. So it's very cool. Let's see, what node? And how long each of the areas is the run. All right, it's gonna go do a bunch of tools. Eventually, if I use this a while, you can start to trust it, and you can say always, but for now, we'll just say once. So it found an error in that first call, and then it realized it and adjusted it and wants to run again. And here is the correct answer. Now these are the nodes that it ran on: standard, high CPU, GPU, and standard again. And here's a report. Very nice report talking about each one. The job used all 90 CPU cores in the high CPU partition. Nice. And requested 351 gigabytes of RAM. So a very cool and very intense run. Intelligently scheduled across the different nodes. All of this was basically done with Gemini CLI. I didn't have to really tell it to do any of these things specifically, but the whole idea of running on different nodes was an experiment that I wanted to do. So I often wondered now if I could take this, let's see, how can I make this experiment? Interesting and longer running. And we create something that we can visualize with a MP4 video along with the data output. So awesome. So now we'll have this astrophysics experiment, see if we can expand it and do something interesting with it, like like I said there, have it so that we create a visualization at the end. So everybody likes a good visualization, especially at supercomputing. So here it wants to do all kinds of things. It wants to so make it more realistic and computationally intensive. We can change the following parameters. Increase the data duration. All right. Double the data quality. Okay, cool. Make the signal harder to find. Will reduce the signal to noise. Oh, okay. This is signal means the whisper of a gravitational wave is such fainter. Okay, yeah, awesome. So we'll increase the detection rate of the signal to noise ratio to see if we can find even harder to find gravitational waves. And then we'll see if we can visualize it. The new tool will be FFmpeg, which is fine. And it's going to add it to our micro Mamba environment automatically, which sounds great. Enhance the workflow would look like this. Generate this 128 seconds of high quality noise, faint signal, run the longer search, if high CPU mode, perform the rigorous analysis, generate video frames, upload it, and hopefully we can visualize it. All right, let's rock. Okay, looks great. Okay, looks great. Build this, run this. What the hell? Okay. Oh my God. I was stuck in edit mode. Let's build this in a new project folder to keep things separate. And then shoot some. And let's run it and feel and watch the run to make fix any errors along the way. We can also profile around if it seems to be the also create a README file in that directory that says everything doing details. later. Okay, so now it should go off and do everything that it needs to itself. Has been working like this over and over again in a really great way for me. Once in a while, there's errors, so you have to kind of watch it, but I've made some amazing progress doing these types of things. Modifying scripts for enhanced experiment. This edit function seems to fail quite often, and it has to revert to just recreating the file, or it performs what looks like a sort of um, GitHub style diff. Right here it is. And then it shows the additions and the subtractions to the file. So now it's moving on to the video file. So fmpeg, uh, basically slicing together all the individual frames, making a video. It's done. It's done. Now it's gonna, I want to check. Old for batch, go to stage 5, plot, move. Oh, okay, yeah. So wants to change the name. Yeah, this is awesome. So here it's going to install the necessary packages so that we can do this and activate the right environment. Well, it installs the packages in the correct environment and then activates the correct environment within the submission script, within the run. Okay, here's a job submission script with dependencies and it's updating the stages. So each job depends on the others. And okay, now it wants to go through and create the software environment and install all the tools within it for this to work. Astro environment. Wow. Hopefully some of the packages that it tries to install don't require commercial licenses or anything like that. Hopefully it's all open source. I think we'll get a good chance to see what it looks like here in a second. Possibly. We'll see what the output is of the installed environments here. If not, we can double check anyway. We can just ask it to tell us afterward. With this tool installed, really don't have to remember to do or how to do any of the different commands. We can really just start to ask it to do things and just converse with it and work with it. I really wish I would see more of an output on this, but looks like it's running in the background. So when the blinking happens like that, I think it's coming through in the video. That seems to be that the screen is refreshing very fast, like there's things happening in the background window. So it looks like it's maybe wrapping up now. I'll go on mute for a second. Okay, here we go. I'm getting some output. I'll go on mute until we get some output we like. Sorry, I'll chime in here. Looks like these are the packages that are getting installed. Actually, there's a ton of them. 323 packages because there's, dependencies on the different software that we're installing. the zlib-ng, a lot of things need that. And likewise with the rest of them. This is a side note. This is sort of one of the downsides of having many different Conda or Mamba environments. These are Python environments or Python environments that are isolated. Isolated is great because they're reproducible and you can keep them and they're isolated and they don't interact with anything else. So they're stable. But they need to have everything included with them so they can function. So they carry everything with them. So each environment is quite big, or it can be quite big. It can actually be huge depending on how complex you make the environment. So for example, we're just doing this one astrophysics simulation right now. I have to go back and see how many or what packages are actually being used. Python libraries are actually being used to do this simulation. But likely it's not more than like maybe three or something like that. But those three Python packages, their dependency chains explode into what we see something like this, 323 packages. Oftentimes it's really difficult to install packages on a high performance computing cluster because there's so many different dependencies and it makes it quite difficult. So Conda environments are great for this, although they can get quite big in your home directory if you have a lot of them. Another way to do containerized environments is with containers, isolated environments with containers. They can be compressed so they can be smaller. But sometimes it can be difficult to get the workflow and the software itself containerized in a way that it acts the way that you are used to it acting or it's expected to act. With Gemini CLI, it also makes this quite easy. So in fact, I think once this is done, we can try and in a different video, perhaps, we'll take this workflow and we'll turn it into a container. All the software packages will be within the container. And we'll do something like we'll run this whole workflow, but every job that runs on the different nodes will actually be loading this container with all its software embedded in it, and it runs from there. While this is still loading, I'll keep talking. That's a really cool and modern way. Containers, this is a really cool and modern way to capture your research workflow for reproducibility purposes and peer review purposes. If you're going to be submitting your work and your research to a paper or like a publication, you're going to publish your work, uh, particularly and in other places as well, but particularly in peer-reviewed journals and such, where others who are reviewing your work before it's published will likely want to see if they can reproduce it. And this also becomes a real problem today in research because containerization and reproducibility is not widespread. So the reproducibility of the results that people are trying to evaluate for paper submissions to journals are often very difficult to evaluate, particularly in computer science, where they have very specialized environments or hardware. Okay, this is done. Hopefully it'll pick up the next part. It will, yep, here it goes. So it installed the software in the environment that we needed, and that all worked successfully. Now it wants to launch the job. I am going to launch the job, but I want to check my current queue first. Yes, let's launch this new job. So first, let's check the queue. Let's see what's up. Ah, okay, cool. So it looks like my jobs are all finished, which I think we did, and yes, we will show and should proceed. So now we're going to launch this new astrophysics workflow, a professional astrophysics workflow. Here it goes. It's the command, and I wanted to run it. Yes. Okay, perfect. We got an error. So it's going to see this error, react to it. That's perfect because this is a part of the setup of the environment. And now it's going to review it and it's going to cancel everything so we can start it again. Starting it again. Oh, same problem or similar problem. It's trying to incrementally change the memory for the video job. I'm not sure that's going to be enough. Okay, so um, now we're going to be sorting out the workflow here. It says this is excellent. Uh, okay, it's going to check back in 5 minutes. Uh, that sounds good, but let's check the logs right now and see if there's any more information there. Check the logs and other tools to see what we can find out about this run so far. So I haven't gotten it to actually go out and talk to the nodes yet, like SSH out to the nodes yet. It should be possible. It's possible on normal HPC clusters. I'm not sure if it is on this setup exactly. That would be a way to go out there and find out some resource utilization on the node to make sure it's actually doing what we thought it's doing on the node and being resource efficient. But other than that, we can check what we can check here, which is usually logs and yeah, Slurm outputs. So let's see what it says. Yeah, the first job went really fast, which I didn't expect either. So, uh, So I didn't find any errors. The job finished so quickly, SStat won't work, and we need to use SAccount to get the final performance data. Okay, so it all finished so fast that it's suspicious. So let's take a look at what we can find out here. Workflow is behaving as expected after it analyzed the SAccount output. See, this is amazing. These are all commands that would be very difficult to look up by yourself or remember over time, like these commands here. So this is awesome. Yes, let's do that. Okay, so maybe it didn't remember correctly either, but the one thing that it can do is figure that out fast, and I can't. I can't get past the main process since we know cleanup phase, close to finishing. Let's check the queue again. So profiling is kind of catching it. Oh, good. It's going to try and SSH out to the node. Oh, I love this. Let's see. Yes, do this. Ooh, we can't SSH to the node with the host key. Ooh, S control can tell you a little bit about the node, but not like SSH to it. SSHing to a compute node is often quite helpful. So there's a lot of elements happening here. It looks like the job is working through it, but everything correctly. It's just that Gemini CLI is kind of freaking out about it. Uh, about checking it, and sometimes it's spinning its wheels, checking the wrong things and making errors. What is it doing now? Editing file for what? What? There was some placeholder solder simulation in there? That's crappy. I don't know if that's true. Hopefully it's not all messed up. Okay, it's gonna check back in a few minutes after it made some adjustments. Deleted everything and fired it off again. So yeah, sometimes it becomes a little scary. Um, because we start to go into areas where we think everything is starting to break or it's not working. But for the most part, we've come back around. and it really hasn't left me hanging out to dry like some of the other AI tools do right now. Like if we keep plugging on this, we'll get it to work, and keep working with Gemini, we get it to work. Um, I've worked straight through my whole context window a couple times in a row sometimes. I've done lots and lots of work with this. In fact, yesterday I wrote a script to take care of, be a good steward of, and monitor all the resources we're provisioning in Google Cloud into a database that we can manage and query and come up with great information and insights. Um, but I'm managing that whole thing through Gemini CLI as well. So I can converse with it, ask it, you know, common language questions, and have it figure out all the SQL statements to query the database, um, and just give me all kinds of great outputs. I've also asked it to create a email program that allows me to send email via the Google API. Um, Gemini CLI created that very robust email sending script that sends it via Google, Gmail, and the API key. I've used that to, live in my bin directory, and I told Gemini CLI that it is there, and to look at it and run the help file command and see how to use it, and then remember it in its memory. It stores its memory. Oh, the whole job is done. I don't, that seems weird. All the jobs are done. So, in its memory. So it stores all that in its memory. So now all I have to say is, send me an email about whatever. If I get some kind of awesome output, I can just say, oh, that's awesome. Send it to me in an email, or send it to somebody else. And I'll give the address to where to send it. Okay, back to this. It scripted end prematurely. It all ended way too fast. Error gives an exact problem attribute error. This Bibli GW detector has no attribute. Okay. Need to correct the way the gravitational wave transient object on the version of Bibli we have installed. Okay, so it's gonna fix this for us. Wait, it's actually didn't know it offhand, so it has to look it up via the Bibli documentation. So it's searching the web to figure out how to correctly use this tool. Okay, it found what it was looking for, and it's making adjustments to the script. Amazing. This is the work that the research computing system administrator would have to do. Okay, now we relaunched the script after making the adjustments. Let's double check. Damn, these two are running. Okay. Everything seems to be going as planned so far. We're running work on a GPU node, and we're running work. Oh, wait, no. We're currently running on the high CPU and the standard partition. Um, and GPU and the other standard partition steps are pending. Uh, okay. I want to double check and see how many CPUs are running on each node. Just curious. many CPUs in memory are we running for each step? I don't worry about spelling too much anymore. Awesome. Stage three, one CPU, one GPU, 15 gigabytes of memory. Stage four, two CPUs, explicitly 15. This is beautiful. Stage five is one CPU and default memory. Here's the table. Awesome. Okay. Let's set this. Oh man, the whole thing stopped already so fast. Ah, so let's look at the logs. This damn LLM sometimes loop. It says at the bottom, I made the exact same mistake again. Okay, it says it corrected the script and it's corrupted file. I apologize. I will completely overwrite. Yes, completely overwrite it. This editing a file in place, which is what we want to do because it cuts down on tokens and different things that we have to mess with. We want it to be very specific in how it makes its edits and not to edit the whole file because it leads to places where it could omit things. But it seems buggy right now. Okay, here we go again. I don't know why there's 5 nodes in the queue right now. That seems a little strange. Um, I want to wait a little less time than 300 seconds before I check again. Wait less than 300 to check again. Cool. Excuse me. Okay, so it's going to check in 1 minute. Instead of just waiting, let's check the logs. Okay, around these these commands that we use to watch. And so yeah, let's just rotate around these information streams until oh man, the job is done already. I mean, we have to keep going round and round. Let's double check this error again. The new error. Okay. Looks like something simple. Okay, we need to create a PSD file. Um, okay. Yeah, let's do it. Let's go. Okay, so we're waiting another minute. Feel free to jump ahead a couple seconds. That's the problem with some of these automated workflows. You shouldn't be sitting here watching them. Oh, and this is good development. Oh, yeah. Okay, now I should run for considerable time. Uh, oh, yes, it is incredibly frustrating. So one of these scripts is exiting prematurely. Well, doesn't know how to run the correct Bibli API. Search result is very clear. So off we go. Well, let's try this again. So we're making progress. The first two steps are completing. The third one has an error that it's working through. That looks good. I don't like to just wait here. I'm gonna have it do some work while we wait. While we wait, it's like that's less. Let's see what the cluster is. Okay. I thought I was going to try and write something. So check again and continue. Excuse me. Do use. Okay, well, so another error. At least it's not like a looping error where it tries to fix one thing and then it creates the same error as the last time. And then when it fixes that, it goes in a loop. That happens sometimes. It's frustrating that we have to run all these jobs, this whole workflow over and over again to sort this out. But this is kind of what happens when you're running new research workflows on a cluster. You don't understand exactly all the errors you're running into yet. So there's a lot of trial and error in the beginning, a lot of trial and error. So many of the runs that happen don't actually produce usable results. It's just one step closer to an answer or a usable workflow that gives results. As an aside, some of the things that happen on um, the NSF access programs clusters. These are the supercomputers across the nation and the national labs. You can get time on these supercomputers and run their even very, very large work. You can run there. Um, but your work uh, and the efficiency of it needs to be sort of documented and vetted in an approval process before you scale up really large on their supercomputers because we don't want them to be running inefficiently on such a important and scarce resource. So you can run there, but the efficiency of your code needs to be vetted before you run there. So you're not going to be doing a ton of work like this on there, which is an issue for the bigger stuff. You have to do this locally or someplace else. Or, and what usually can happen, or how it plays out is you'll do something at a smaller scale, either locally or on an NSF resource, where you can be a little bit less efficient until you figure out the syntax of the commands, like we're seeing here, until you get it dialed in, the workflow, and ready to scale up. And then once that's complete, you would then apply for a bigger allocation, and off you go and try and run there and get some real serious results on some big compute. That was just a little note about how often the work we're doing on these clusters is a means to an end. It's not actually the runs that's going to give the research output. Man, the whole thing is complete again. That probably means that it failed again with some other syntax error. So let's see. it's reading it right now. Yes, back. Just because I am passing a string object as a positional argument. Man, this is having a hard time with this work, this package. Hopefully, it could do it now. I don't want to wait 180 seconds every time. I just want more action. We're going to check every 10 seconds now instead of every 60 seconds because, yeah, stuff seems to go a little faster. Man, those first two things are fly through. Do they actually do any real work? There's two jobs. Now we're back to configuring. Hopefully it's checking the. Uh, oh no. See, this is disappointing. It's trying to fix that same error over and over again. It's going to override the whole file with the changes. That's unfortunate. So let me get around. It thought it fixed it, but then it made no changes, so it's not going to do any better. You didn't make any changes to that. Please rethink and think through that files, processes, and functions to ensure the whole thing works as planned and double check the syntax um, against against the search results you got. So hopefully I can have it take a step back and analyze what we're doing with this file in a more direct and thoughtful way and rewrite it correctly. Sometimes it sort of starts to trip over its own toes and it doesn't think about everything that it's supposed to do. It gets too excited, perhaps, and tries to bully its way through that. Yeah, my attempts to fix it were clumsy. Hopefully, it realizes this and it does it correctly this time. Oh, I don't like all these different jobs that are here. There's one extra one, so hopefully I didn't see where it added a new stage. Okay, there's 5 stages. All right, there we go. I see it on top. First stage completed, hopefully. The next two are running, and the two after that are pendant. This one's running now. Okay, okay. Don't crash. Ah. I recommend we abandon the Bibli approach for now and revert stage three to a simpler placeholder script that simulates the analytics. This will at least allow the full stage five workflow to complete, generate the video, and upload the results. Let's try before we give up on real work. Is there any other software package we can install that you understand better and will do what we want for the stage or something really soon? You That's disappointing. Good. There's another one. ICBC. Okay. Replace stage three with the PyCBC based script. Sounds good. Do we need to install new software packages? Okay. But do we need to install any is that um, the design? Oh yeah, modify in the environment setup script. All right, let's see if this works. Install PyCBC instead. Damn, this takes a minute too sometimes. What environment are we installing this in? We are installing this in our Astro GW Pro. Gravitational waves. Oh, good. It's not taking forever. Unlinking. Get out of here, Bibly. Bilby. You were too complicated. I guess I can go figure it out myself, but that's annoying at this point. Oh, you're installing. Wait, it's removing the whole environment and installing a new one. Okay, that's fine. Seems a little excessive. We could have just installed the PyCBC right into the other environment and just not use the Bilby, or maybe just uninstalled Bilby from that environment if we wanted to. This is more work than we need to do. So feel free to check back in a couple minutes once this is complete, and we'll try the run again. And if I remember right, that's like 500 megabytes of packages. You have to be careful when using Gemini CLI in your home directory or just in general, because like sometimes it does things that are valid, but maybe not what you wanted to do, like this, for example. Earlier today, I was adding a new entry into my cron tab, which is a mechanism in a Linux system to run things at a scheduled time, like cron, like chronography time. So time-based running of applications. It's a scheduler for applications. So it's one text file where you edit it, but I had a lot of important things in there for a lot of scripts that I run at different times of every day. And I was adding a new entry, and I allow Gemini to do things by itself when it asks, do I want to do it once or always? So many things I ended up doing always, and that's probably a mistake. Like this question here. I should leave it to the once always. So the workflow is edited. Uh, the back to this astro environment experiment. The new environment has been created, it looks like successfully with PyCBC, and now we'll try the run again. Stage 3 should be done by a different software package now. It should monitor everything again like it did before. But yeah, these large language models still make mistakes. Oh, okay, never mind. I thought we were starting the run. We're not starting the run yet. We're actually now going to create the new software environment and install PyCBC. CBC, excuse me. Doesn't look like there's a lot of packages. Oh, only 56 megabytes, but it's still 325 packages. Maybe I was incorrect in reading that last one. Maybe that wasn't 500 megabytes. Maybe that was something like 50 megabytes too. But still, 300 and some packages all working together. Hopefully it all works out. I'm gonna drop the share and come right back again. 1 second. All right, now I'm sharing the whole screen so you can see my little icon to remove this. It doesn't cause a problem. Okay, I'll check back in a second or two. Well, ideally, this workflow would have been recreated uh, or created based on the other one and implemented and run in like half hour so that we could have made this video nice and short. But this video is probably now about maybe pushing an hour. I'm not sure. Um, the amount of work that we've done here in troubleshooting a new workflow is amazing in just in this amount of time. We've written brand new scripts that them themselves may have taken a week or more. Micro Mamba, the environment itself, I only learned about because of this, and it's much easier package to deal with than Micro or Mini Conda. Okay, so the new environment is ready. All the scripts are in place. Let's launch. Go, go, go. It's been a little bit of time since we ran this last run, so some of these nodes may have actually turned off. So it may take another minute or two for the node to actually spin up again. Since these are cloud nodes, they go to sleep or actually just go away. They deprovision over after a period of time. It's configurable. I don't remember what it is at the moment. So we'll keep checking every 10 seconds or so just to make sure that this starts because, and I like to watch really closely, even though Gemini may freak out about it here in a minute. Maybe you'll say, hey, I'm looping. It's running? I don't know. Doesn't seem like it's running yet. Not in that last output. Let's see. There it goes. Okay, yeah, that's running. So we should start to see the other nodes start to kick off as well too. Yeah. And hopefully because they're in a pending state, they will begin the provisioning steps that they need to, so we don't have to wait for them to provision once it's their turn. Because we still have to spin up a GPU node, and we're currently spinning up a high CPU node, and we will have to spin up yet another standard node as well. I think the standard node only has two cores. Oh, no, 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 what happened? Right to be skeptical. My approach is fundamentally flawed. What? You are not doing a great job of showing me and the crowd how good you are when you keep failing. Ah, instead of trying to fix the broken script in line, I will discard it, build a new one based on a known working example. Okay. A clear command line driven workflow using config files is far more robust. Okay. All right. Whatever you got to do, just don't take too long doing it. An injection file. That sounds awesome. What does that mean? Command line driven approach. A lot of new stuff going on. Hopefully it works well. Yeah, let's do it. Do we still get a video at the end? Yes, absolutely. Okay, let's see if this works. Yeah, hopefully these nodes haven't like shut off now because it's only been a couple of minutes since we ran them last. So yeah, the work should hit the nodes pretty quick. And step three done already. Cross your fingers, everyone. Finished. Same temporary state we saw before. The process like very deep provisioning, high CPU provisioning, and GPU nodes. It'll fix itself soon. Yeah, it is. Okay, let's check the output log of stage three. Hopefully that all worked. That was so fast though. Oh no, this is stage three right now. Yeah, this is stage three. It's running on the GPU. Another instant finish, which is a clear failure. I am certainly sorry. Incredibly sorry. I rewrote it. I added the corner. Oh, Jesus. Okay, hopefully. Wait. Don't, I don't want to go through that again. Don't remove the environment. Just edit the environment. Don't remove the whole thing. Jesus, that's annoying. So now it's just running the install script in the micro Mamba environment for that. Oh, we had to downgrade SciPy. Weird. Dependency hell is what people sometimes call the stuff that happens here in this scenario. So check back in a second. Alright. Relaunch the workflow. Fingers crossed. Here we go. Hopefully it checks it every 10 seconds or so again so we can watch it closely. Excuse me. Come on, come on. You kill me with the stage three. We want stage four. We want to make it to stage four. Come on. Wonder how long it's expected to run on this GPU. Or too fast. Not again. Are you kidding me? The name I specified in the inference height is not valid. Mm, a lot of stuff going on there. Um, Perhaps that old workflow is still running. Yeah. Start over. Start all over again. Let's cancel all those jobs and start over. You're making me look bad, Gemini Pro. Create proper run file for Pi CBC. You can do it. The INI file, you know about INI files. I know you do. Don't make you do deep research. You have to look up like 300 websites. What? Stage four is finished. What does that mean? Stage three is now configuring. Check the log up for stage three. Oh, this is beyond frustrating. Oh no, it failed again. I'm clearly missing a fundamental piece of the puzzle. Oh, it's extremely clear now. Oh, so it knows what to do. Definitive fix. I see. We'll see about that. Okay, but it also forgot to clean up the old jobs. You're getting lazy, Gemini. Don't be lazy. Be very thorough with things you don't try to plunge make this big song safety thoroughness. Here, mount. Maybe I'll pause it. No, I'll let it run. You guys can see the enjoyment as well. System administration. I'll mute it for a second. I feel like it's gonna fail again. When it does, I'm gonna have it run tests on this one package in a simulated experiment so that we can figure out how to correctly run this job without running the whole thing. Yes, clear the queue, but I know before we go back to the full workflow, I want you to develop a test job, one job that we can use to debug this stage 3 issue. So we don't want to run the whole workflow each time while we sort this out. The test must be exactly compatible and create and use test inputs for this stage if needed and as needed, but this should be one job that we can run over and over fast to troubleshoot the syntax issues and syntax and other stage 3 issues. All right, so let's see. It's an excellent and highly efficient strategy. You're right. It's very, what do they call that new word? Sycophantic. Oh, you're so amazing. Yeah, that doesn't work. That command. Oh my God, what the hell? This is Be careful, raise the gauge. Let's inject a bunch of different errors. Let's go down this rabbit hole. Yeah. Nice. Oh no. Come on, you can do it. Get through it. You can do it. I'm gonna let you run. I'm gonna put it on mute and we can watch. My approach was completely wrong. All right, let's see what it does. Still has problems. Okay. That looks like a complicated field array. Go out to the internet, sure. Good. Hopefully it actually finds the results. These are must Astrophysics isn't the most available in terms of information, scientific discipline out there when it comes to software and packages. And it's often, in my experience, which isn't deep, but in my experience, it's not very um, up to date or new or modern. And there's some a lot of old methods around and leftover bad habits and such. And lack of documentation. Look at all this new stuff that it added. So hopefully this is how it works. Mm, Creepers, creepers. I'm glad we're doing this in one script and not running a job every time. So we can reiterate quickly. HDF5. We're creating an HDF5 file system. That's awesome. It's it's like a file system on a file system, but it helps with organizing and accessing files quickly. Test data generation complete. Wow, but it's actually using some packages that don't use it anymore. Well, it completed, so whatever for now. So this is a good time to say that we would If we had a container, we could capture this at this point in time. And if we got it to work and containerize the workflow in the software environment at this point in time, it all would work. But that warning back there said that, possibly maybe in a year or something, or sometime in the future, this won't work. Okay, so the test of hardiness is now complete. We have our test data, our debug configuration, and our standalone bash script. Let's submit this debug job to the queue. This will allow us to rapidly test and resolve the final issues with stage 3. Yes, please. Go, go, go. Go, go, go. While that's configuring, I'm wondering how the test job was different than on a CPU machine. A small one was different than the real job on a GPU machine. How was the test job different than the on a CPU machine versus a GPU machine test? Like we are doing now. Part of our stage is always a process called Markov chain. Oh, Markov chain Monte Carlo sampling. Look at that. Very smart guess algorithm, right? Nice, nice. It runs many walkers. Potentially, yes. Small parallel groups. GPU machines can use thousands of smaller. So, okay. Okay, let's continue. Hopefully, it just understands what we were working on in general right now. Okay, well, hopefully, geez, hopefully that's done and didn't error. Can't find the log file, so check the submission. Wait, to see. Yeah. Um, Tisk, tisk, tisk. It ran in the wrong directory. Good. Now it's gonna run again. Fine. Let's see if we can get the correct output files now. Still don't know if this worked. I'm gonna wait for it to configure. Hopefully it just runs. If I can remember easily how to do it, I would reconfigure the cluster to make sure that the GPU nodes don't deprovision so fast or leave one up all the time. But that's wasteful. Maybe just have them deprovision like 3 times the time. You can, yeah, it's no file yet. It's just still configuring, hasn't started running yet. Super frustrating. Okay, yeah, still configuring. We haven't even gotten back to the real workflow yet. What's this? Oh, S control. Nice. No, 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 don't cancel this. Our cloud nodes and sometimes take a while to provision. As after they are not while they see provision. Some about this. It's a lot like our in short, let's keep oh, I don't know if you were following that, but there were some more failures. This time it failed right away and it still wasn't producing any log files, which means the script itself was failing, so it checked that, well, it had a theory about why that might be the case, and it made some edits, and then we're trying again. Um, it's configuring. I'm sleeping for 10 minutes, still configuring. 10 seconds, and it was checking again. Okay, I'm now going to sing the Star Spangled Banner for you. One, two, three. Oh, sorry, I was on mute. Here I go. I'm going to sing the Star Spangled. Maybe sing Jimi Hendrix's version. One, two, three. Yeah, that was amazing. My hair stood up. So look, the job is running. Hopefully it checks it again in a second. Maybe it'll check the log files here in a second. Yeah, please check that. Hopefully there's something good in there. Success to debug reveals the core problem. Oh, problem. The solution is, oh no. So I'm gonna try it again. Oh, I don't really trust your definitive fixes. So let's see. Go. Killing me, Smalls. Well, this damn no, it shouldn't need to be reconfigured again. It should just still be up from last time. So as you can see in the corner of my Gemini CLI, I still have 71% context left. So a lot of the things we're dealing with and everything that it sends back up to Gemini every time we talk to it, we still have 71% of that sort of like window of text available to us. Yeah, there's no log file yet. It's not running yet. No, it's not unusual. Don't freak out. Okay. Yes, wait patiently. Oh no, the job finished so fast. Ah, not again. What is going on? You may have been checking the old log file and seeing the same errors. Yes, this is the log file here you want to look at. Lazy. Too fast. Examine the error log in the same location. Here we go. There's an actual real error of why. No, no, no. So I tried to edit the file and it made no changes. uh, the error inference error, unrecognized arguments, low frequency cutoff is 20. This is the same class of error as before. Must be specified within the INI file. I have made a mistake and apologize. How now correct the debug. Okay, we didn't actually add it to the INI file. Rewrite the INI file so you don't miss anything. Hmm. Face out. Alexa, what's the notification? Hmm. And using what we learned here in this test to implement the correct changes to the large astro work flow that was on stage. Okay, let's submit this again. Please don't let this take forever to configure. All right, job's running for 8 seconds. Should be enough to fail, hopefully. Yeah. Fingers crossed, everyone. Oh, come on, man. Try again. So we have to wait another minute. At this point, I'm getting a little tired. We might want to come back a bit later. So we may pause the video and come back later. It's a little frustrating, but we'll see if this next one completes. Hopefully it does. And we can just carry over the lessons learned to the larger workflow, kick that off and see it run like in the next 20 minutes. Okay, we're running for 10 seconds. Jeez, let's see. 13 seconds. So, trapped in a loop of failure. Okay. Try next one. Okay, let's try it with everything in the config file instead of in batch script. It's gonna make we wait another minute more before we can see if this worked. Less time before a break. Historically, it's been taking around a minute to provision, so it should start soon. We should know any minute or any moment. Here it goes. Mhm. Likely running correctly. Oh, it stopped pretty quickly, but hopefully this is just a test. Okay, so it thinks it knows the answer now. It's another edit and another edit. Okay, I'll check back in a couple of minutes or in a minute once it starts or something changes so you can see. Oh, sorry. I didn't resume it last time. Um, yeah, it's it found another error. But it said it knew exactly what the problem was now. Aha, the root cause. So I fixed it. Oh, look, it's running, and let's see what happens. No. But they changed. So what's okay. It found some issues. Um, even searched the web to get some clarification. Made some edits, and let's see. It's a trap. I've been here for a long time because I keep thinking it's going to be right around the corner. This is exactly how I spent the entire day yesterday. Well, we should know in about 20 seconds or 5 seconds whether or not this worked. Whoa. Okay, so we switched that configuration parameter around. Seems silly. What about that test script we were running? That was a lead thing. Did we not test apples to apples? I am uh, assuming. Our previous test wasn't a successful test at all. That's ridiculous. Uh, adding them both back. Do you really need to add both of those back to that section? Should we leave the cut off of there still? You're about to repeat a previous mistake. That's BS, man. You're making a bad, you're not doing a good job. Okay. Yes, let's run this again. But first, let's adjust our test script to be a true test script that tests all options that we are trying to do in the real test and the larger workflow astro pro that we are working on. Don't forget about that. About the overarching that. Okay, hopefully we can be a little bit faster about our iterations and not waste too much time translating back and forth between the tests and the environments. Can we test the test script first, then continue on? Should have submitted it to a job. Well, in about 20 seconds or so, we'll know what the heck just happened. Yeah, it's like, yeah, 'cause it's not running yet, but there was a lot of back and forth of different directories, so hopefully it's got it all straightened out. It was a while between that last run and this new run, so it may take longer for the node to launch. Okay, here it goes. It's been running for 12 seconds, 13 seconds. Usually it's been stopping around, so hopefully it's better. Let's see. Output final. Okay. It's a little bit of a different error, so that's kind of good. They generated some test data in a different place. All right, one last time on this GPU node, and then I'm gonna see if I can get it to run like on a script. Or maybe I'll even go further down the rabbit hole and see if we can get an interactive session on a GPU node and test it in an interactive script, or not a Slurm submission script, but actually just get on the node and try and run all this from the node in a single script so we can get it going faster. Are you kidding? Are you kidding me? It just keeps making these dumb mistakes. What's going on now? When you it's pending because the old one didn't stop yet. Well, Didn't realize this was going to be so complicated of a test. I forgot to turn it back on. By the way, we're doing some more troubleshooting. We're getting along. We're getting away, as you can see right now. It's actually running for a while in the test script, but then still failing. It turns out that this was a very complicated example, but we'll keep working through it and see if we can get it completed. Getting closer. These are things that I think we can solve sometimes. The other ones are harder, like dependency issues can maybe never go away, but sometimes just like wrong strings, yeah, hopefully that'll be okay. This is some crazy math, I think. Uh, is that the same error or a different one? Come on, Gemini. I'm burning through my context. I see it at 48% now. This is a data corruption issue. Holy hell. That sounds serious. Corruption issue. Oh, goodness. Oh, come on. Import. No available sampler. Back to the EMCEE. We've been around this before. This looks like maybe another loop. Oh no. Man, maybe we can try a different sampler. Okay, yeah. Well, I don't know why you didn't do that last time, but yeah, I don't have a lot of confidence you could do it this time either. So at this point, let's see. And then I'm going to stop you and tell you to use a different sampler. Okay, what is a sampler in this context? And can we choose a different one from the list, a better understood one, perhaps? All right, for asking the question, a sampler is a statistical engine for the heart of the pi C. B, C interface tool. Explores the landscape to find that peak and okay. A better understood sampler. Why is dummy a sampler reconsidered? Switch my sampler to debug interference. Okay, it switched to a different sampler and is trying that now. That was a little fast. Another error. So cannot use a dummy sampler. We must use one of the other available samplers. Why are you going back to the multi-test one, which you know doesn't work in how you think about it, at least? Let's let it chew on this for a few times. Right, did we delete it last time? Jesus. So like import it again. I think it's getting, I'm gonna have it. The statistical checkpointing. Uh, and also multi-nest isn't installed. Going to compress the context because I think it's dealing with too much at once right now. And it's having a hard time understanding what we're trying to do or what it's trying to do. This takes a little pause and come back when it's ready. Oh, here it is. Okay. Continue. We talked about doing all the things here a second ago, right? Yes, let's run this again. But first, let's test and adjust the output. Okay. Uh, Same error. So let's see how this refreshed context, compressed context window can handle this. Mm, Check feature. Okay, I'm gonna turn it off. Okay. Uh, try, um, same thing. So, what do you gotta say about that? Goodness. Come on, Ultra Nest Sampler. Oh no, I just spoke this. Oh no. No available sampler named Ultra Nest. You loading Ultra Nest. Try it again. We disabled checkpointing entirely for the INI file, so we think. Which makes sense because it runs for a little while that tries to checkpoint, I think. Looking for a checkpoint file. Yeah, it has to do with checkpointing. So stop trying to checkpoint. It's a good approach. Yeah, I don't have a lot of hopes in reinstalling nice by pi. Maybe I have it double check the file system itself and see if it's compatible with H5 pi. Downgraded H5 pi. Let's see if that works. Wow, the same error. Rebuilt this stack, switched samplers, trying again. Same error message. Okay. Ugh. Just me, puppy. Oh. Let's see. Oh my God, I fixed it. I fixed it. There's a compatibility issue between HDF5, really crazy file system within a file thing, and NFS file system. So if you're running it on the local disk, it seems to work. Maybe we can scale the whole thing right back up. Let's see. What? Yeah. Before we run this, is everything in place? The directories, the files. I didn't stay on top of it. Let's see how it goes. Some strange names for the job names. I don't like that. Hmm. So hopefully the job IDs are within the error files and the output files so we keep things organized. Okay, things are starting to run, and more things are starting to run. Good. Go, 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 go. Give us a video at the end of this 4 hour thing. Come on, high CPU node. You haven't let me down yet. You can do this. Still configuring at a minute 41. I think around 4 minutes or something like that. It's probably too much. Yes, it's running. Okay, this one's, I thought was pretty quick too. But we're off to stage three, which has been the one that's been hanging us up. We're moving from test data to real data in the inputs and outputs of this workflow. So there's variability there. All right, all right, all right. Stage two is complete. I don't really want to interrupt it to go ask it how stage two worked, if it worked okay, but we're about to find out. Usually took about a minute, minute 30 for GPU node to come up. So we should know. Oh man, here it goes. It's running. Don't fail, don't fail, don't fail. seems like this is something it thinks it can fix. So let's go. Okay, I gotta go. Let's see if we can get this run while we're gone, and I'll give you an update later.